The orders page has been fine for 3 weeks. Nobody deployed anything. On your laptop, it still feels instant. This morning, in production, it is slow. Not broken, no error, nothing to screenshot. Every row on it is correct. Just slow enough that support noticed. And support does not usually notice. So you turn on query logging, load the page once, and open the log. 201 queries. You wrote one of them, the one at the top. It gets the orders. It is the one you meant to write. The other 200 are the same query over and over, with one number changed each time. They are not in your code. Nobody typed them. Something is talking to your database 200 times a page, and it is not you. Your app and your database are two separate programs, usually on two separate machines. There is a network between them. Now look at this. See the dot, order.customer. That dot looks like every other dot you have written. User.email, self.total. Just reading something that is already there. It is not already there. When that line runs, your code sends a question across the network. Then it waits. The database answers. The answer comes back across the network. Only then does your code move on. It is not a dot. It is a phone call. And your ORM did that on purpose. When it fetched the orders, it had no idea whether you cared about customers. Loading them every time would waste work on every page that never asks. So it hands you an order with an IOU attached. And the moment you touch that IOU, it goes and gets the thing. One dot, one phone call. Now put it inside a loop. 200 orders, 200 different customers, none of them loaded yet. Query 1. You ask for the orders. One question, one answer. 200 rows. This is your query. It is doing its job. Now the page draws itself. Row 1 wants a customer name, so it touches the dot. Phone call. Row 2, phone call. Row 3, phone call. 200 rows, 200 dots, 200 phone calls, one after another, each one waiting for the last to finish. One query to get the list, one more for every row in it. 1 plus n. That is the name. The n plus 1 problem. It is one of the most common performance bugs there is, and you have probably shipped one. Now, here is the part people get wrong. Nothing here is slow. Each of those queries is a lookup by ID. The database answers each one in well under 1/10 of a millisecond. There is no missing index, no bad plan. Every single query is excellent. The database is not slow. You asked it 201 separate times. This is why the bug got through code review, testing, and staging. It works on your laptop. It has always worked on your laptop. Most explanations get this wrong. They say it does not happen locally. It absolutely happens locally. Same code, same loop, same 201 queries. Two things are different, and neither of them is the code. 1. Your test data is small. Your laptop has 20 orders in it, not 200. 20 orders is 21 queries. 2. And this is the real one. Distance. On your laptop, the database is on the same machine. The phone call goes down the hall. In production, the database is on a different machine, in a different building. The phone call goes across town. Call it 1 millisecond, each way, every time. Your numbers will differ, the shape will not. Now think about what that millisecond is made of. The database does its work in well under 1/10 of a millisecond. Same database, same work, both times. So almost all of that millisecond is not the database doing anything. It is just distance. Do the maths. On your laptop, 21 quick calls down the hall. You cannot feel it. Nobody can. In production, 201 calls across town. About 1/5 of a second spent purely waiting before your page has drawn a single pixel. Same code, same loop. Nobody changed anything. And it gets worse because this stacks. Say each order also lists its items, and each item shows a product name. That is another 200 calls for the item lists, and at 5 items each, 1,000 more for the products. 1,401 queries. Now you are waiting closer to a second and a half. That is when a page stops feeling slow and starts feeling broken. Here is the whole fix. Stop asking 200 times. Collect the IDs first, then ask once, 2 queries, 2 phone calls instead of 201, a couple of milliseconds instead of a fifth of a second. And here is the bit that matters more than the number. The count stops growing. 200 orders, 2 queries. 500 orders, still 2. 1 query for the list, 1 for each kind of thing you attach to it. Not 1 per row. Your ORM already knows how to do this. In Django, it is select related and prefetch related. In Rails, it is preload. In Laravel, it is with. Every serious framework has it, under some name. So why does it not just do it automatically? Because it cannot read your mind. When your ORM handed you those 200 orders, it had no idea you were about to loop over them and ask about customers. It found out the same moment you did, 1 row at a time, when it was already too late to batch anything. You have to tell it. That is the whole job. Finding the bug is easy. Fixing it without making a new bug is the part nobody shows you. 2 traps. Trap 1. Just join it. This is what someone will suggest first, and for a customer on an order, it is right. Each order has exactly 1 customer. Join them. 1 query, done. Now try it where one thing has many things. 50 blog posts, 4 tags each. You join posts to tags and you do not get 50 rows. You get 200. Each post comes back once per tag, and every column of that post gets copied 4 times. And now your limit 50 is counting the wrong thing. It is limiting joined rows, not posts. 50 joined rows is about 12 posts. You asked for 50 posts and got 12. You fixed the phone calls and broke the page. When one thing has many things, do not join. Ask twice. Get your 50 posts. Then get all their tags in 1 more query. 2 queries, 50 posts, every tag. And most of the time, your ORM does exactly that for you, the moment you paginate. Trap 2. Prefetch it, then filter it. You reach for the right tool. In Django, prefetch related tags grabs every tag for the whole page in 1 extra query. 2 queries total. Perfect. Then you write this. And the phone calls come back. 1 per post. Django did not throw your prefetch away. It is still sitting there. Post.tags.all would still be free. But filter is a different question, and the answer Django saved cannot answer it. So it goes back to the database. Once per post. You paid for the prefetch and you paid for the n+1. The fix is to filter the tags you already have in your own code, instead of asking the database again. 1 rule, 9 words. Never let your code make 1 phone call per row. That is it. That is the whole video. For a thing that has 1 other thing, a join gets it in 1 call. For a thing that has many, ask a second time and get them all together. The names change per framework. The idea does not. Look at Laravel. Same word in both columns, and it never joins at all. It just always asks a second time, which tells you the rule was never really about joins. It is about how many times you pick up the phone. 3 honest things, because most videos skip them. Small numbers are fine. 3 extra calls is a few milliseconds. Rewriting your query layer to save a few milliseconds is exactly what people mean by premature optimization. This matters when the number is big or the page is busy. At 3, walk away. Fewer queries is not automatically better. One giant join that copies every row 4 times can be slower than 2 clean queries. What you are counting is phone calls and how much comes back down the line, not queries. It is not your ORM's fault. Same bug with no ORM anywhere. A loop that calls an API once per item. A loop with handwritten SQL inside it. One service that quietly calls 200 others. N+1 is not a database problem. It is what happens when a phone call is hiding inside a loop and does not look like one. One thing, turn on query logging. Load one page. Count the queries. If the count goes up when the page gets longer, you found one. Then lock it. Django has assert num queries. Most frameworks have something like it. Write a test that says this page uses 2 queries. The next person who drops an innocent-looking dot inside that loop will find out before your users do. You wrote one of those queries.